Okay, year 12. So the next thing we're going to be looking at is power functions. So basically, we're first going to be looking at x to the power of 1, and then x to the power of 2, x to the power of 3, -1, -2, -3, and so on. But also x to the power of 1/2, x to the power of 3/2, and so looking at fractional powers as well. The first one I wanted to look at is, as an introduction, is 1 over x. So you can see here we have the general form, y equals a over b times x minus h plus k. If a is 1, b is 1, h is 0, and k is 0, as we have on the settings at the moment, what we're going to have is just the graph that we can see down here is just 1 on x. Okay, and then we can start to talk about what all of these things do. Now, we should be somewhat familiar with this from the transformations unit that you did. But basically, this a value at the top is going to be a dilation by a factor of the magnitude of a from the x-axis. So we're just taking the positive component of that a value, because if it's negative, it's a reflection across the x-axis. Okay, so let's see the effect of changing that a value. Let's change that a value to 2. So that a value goes to 2. So that's a dilation of a factor 2 from the x-axis. So we're sort of stretching it this way. So you can see the point 1, 1 becomes the point 1, 2. Okay, and similarly, if we reflect it, let's say a is -1, it flips it across the x-axis. So it sort of went like this, and now it's like this. Okay, let's see what happens. Let's put it back to normal. Let's see what happens if we change the b value and what effect that has. So again, we know hopefully this is a dilation by a factor of 1 on the magnitude of b from the y-axis. So now we're thinking about compressing and stretching sort of in this direction. When b is less than 0, there's a reflection across the y-axis. Okay, so let's see what happens if we make b equal to 2. Okay, we can see that the point 1, 1 got mapped to the point 1/2, 1. So again, let's just recall that we have a b value of 2 here, but that represents a dilation by a factor of 1/2 from the y-axis. So all our x values get halved. When b is less than 0, there is a reflection across the y-axis. Okay, so let's make our b values negative, and you can see it's a reflection across the y-axis. Now this function, this type of function up here is called a hyperbola, and it so happens that when you reflect a hyperbola in the y-axis or the x-axis, it has the same effect. So that's why changing a to be negative or changing b to be negative is going to give you the same result. So you'll notice that that's similar to the graph. It's the same as the graph that we had before. Okay, so let's put that back to +1. So we're just at our usual. Okay, and then we've got these h and k values, and those h and k values have meaning. So let's have a think. Okay, let's look at the k value first. If we change the k value, we can see that our horizontal asymptote moves up and down. So our horizontal asymptote is going to move up or down. If k is greater than 0, it moves up. K is less than 0, it moves down. Okay, and similarly with our h value, if our h value is greater than 0, it moves to the right. If it's less than 0, it moves to the left. So they become our horizontal and vertical asymptotes. Okay, and then finally, let's just talk about, our asymptotes are, vertical asymptote will be at the equation x equals h, and a horizontal asymptote have the equation y equals k. And then let's just talk about the domain. So we're just set back on 1 on x, just the usual most basic function. So we can see the domain is going to be from -infinity to 0, but not including 0, and then from 0 to infinity. And then similarly, the range, you probably guessed, is from -infinity to 0, but we can't include 0, and then from 0 up. Okay, so that's for the graph of 1 on x. And so basically, your range is going to go from -infinity up to your horizontal asymptote, and then from your horizontal asymptote up, but you can't include that point. And your domain will go from -infinity to your vertical asymptote, not including that point, and then from that point to +infinity. So yeah, that's an important thing to think about. Now, just keep in mind these a, b, h, and k values as we go through this are always pretty much going to have the same effect. Okay, so a is always going to be a dilation by a factor a from the x-axis. B is always going to be a dilation of 1 over the magnitude of b from the y-axis, and so on. So you see what I mean here. If we look at this example is called a truncus, where we've got 1 over x squared now. So if we look at this function here, this red line, is 1 over x squared. A is 1 at the moment, B is 1, H is 0, and K is 0. Okay, and yeah, asymptotes are again at H and K. So if I change H to be positive, it moves it to the right. So my vertical asymptote there is at x equals 2. And, I can move my K value if I move it up. My horizontal asymptote is also at 2 in this case. But we can put it wherever we like. Okay, let's just put it back to normal. Okay, so if we change A, again, dilation by a factor, in this case, 4 from the x-axis. And similarly, change B. Now, this would be a dilation by a factor of 1/2 from the y-axis because it's 1 over B. Okay, now for the basic function 1 over x squared, where H is 0. Hey. Okay, so kind of forgot where I got up to, but that's okay. So if I do K, that moves it up. You get the idea, hopefully. If I change H, that moves it to the right or left. Yeah, and having information about H and K can tell you your range and your domain very easily. So our domain is going to be from -infinity to 0 because that's our vertical asymptote, and from 0 to infinity. More generally speaking, our domain is going to be from -infinity to our vertical asymptote, not including that x value, and then from that value to infinity, unless there's some other sorts of restrictions on it. And then the range is going to be from 0 to, it's going to be from your horizontal asymptote up to infinity, unless it's been reflected, in which case it's going to be from your horizontal asymptote down to -infinity. So just got to be aware of those types of things. Okay, so that's 1 on x squared. Let's do the next one, which is the square root of x. So x to the power of 1/2, essentially. So fractional powers. Now you've noticed in the previous two examples, H and K were our horizontal and vertical asymptotes. In this case, it's actually going to be our endpoint. So let's change H and K. If I change H to be 2 and then K to be 1, you can see that our square root graph starts at the point 2, 1. Okay. And if we just think about the most basic graph, and put those back to 0, 0, 0. Think of our most basic graph. The domain is going to be from 0 inclusive to infinity. You can include 0 because as long as the square root, what's under the square root is equal to 0, you're fine. And then the range, as you can see, is going to be from 0 up to positive infinity. Okay, so that's, and then obviously again, dilation by a factor of 2 from the x-axis, dilation by a factor of 3 from the y-axis. Dilation a factor of 1 over 3 from the y-axis, and then obviously reflection in the y-axis, reflection in the x-axis. So last one, let's put these back to normal. Let's make B 1. Let's make K 0. Okay, so now we've got the cube root of x essentially. So if we let's make these 0. We've got the cube root of x. So we can see here we've got the cube root of x. Let's start with the domain and range this time. There's no restrictions on the domain. You can have all real numbers, positive and negative, including 0. And the range is going to be from -infinity to positive infinity, so also all real numbers. You'll notice now that H and K, so in the 1 over, in the negative powers, they became asymptotes. In the square root graph, they became, H and K became endpoints. But for the cube root, H and K become the point of inflection. So at the moment, H and K is 0, so the point of inflection is at 0, 0. But if I change H to be, let's say, 1, and then I change K to be, 2, the point of inflection now is at 1, 2. So hopefully you find that helpful. We'll talk more exactly about different power functions and then stepping through it, even powers, odd powers next time. But I hope this helped with sort of transformations as well, because you can sort of see the similarities across all of the graphs. Okay, and maybe it'd be good to see what a reflection in the x-axis looks like for this. Looks like that. And let's have a look at a reflection in the y-axis. reflection in the y-axis. If I change that back to 0, if I change that back to 1. Okay, that's a reflection in the y-axis for the graph, y equals the cube root of x. Okay, hopefully that's helpful somewhat.